Morning guys, got a fun one today. Go ahead and get into this. I'm down in the basement before work. Woke up this morning with no hot water, so that's always fun. I'm gonna go ahead and see if I can diagnose this before I head out for work. Go ahead and verify that we have line voltage coming in. I already checked the breaker and it's not tripped, so right here, yeah, we got our 240 volts. And let's see, we have no voltage going to the top element. That element should take priority, and the tank is completely cold, so it should be turned on. That one is not. Let's see. So that indicates that's like a thermal reset, where if the thermostat reads the water heater getting too hot, it'll trip it, which over the past couple days, this thing has the water has been extremely hot in it. So I imagine one of these elements is probably going bad. Usually these elements will say right on the side of it what the... So at 240 volts, this heating element is going to be 4,500 watts. So we can take 4,500 divided by 240 volts. We should be getting 18.7 amps with this element running. Change this over. Check this leg and see. So we got 19 amps on that leg. 19 amps on that leg. So it seems like that element is functioning properly. Let's check the bottom one. So to trick this thing, you can actually take and adjust this thermostat to make it basically think that the temperature is satisfied, and that'll kick on the bottom element. Which this water is still cold, so that might take a little while. In the meantime, while that's heating up, I'm gonna go ahead, just out of curiosity, keep in mind when that thermostat up there is satisfied, it's gonna energize these wires, so definitely watch out for that if you're working on this. But I'm gonna change over to continuity and go ahead. Typically these bottom elements are gonna be the ones that burn out, so I'm gonna see if we have a total failure here while we're waiting on this water to heat up. So I have continuity, and I'm reading about 13 ohms. So that's probably right in the ballpark of where we want to be. So we know that element is not totally burned out, so that's a plus. I just gotta wait for this water to heat up. And then we can check the amp draw on this lower heating element, which I might can trick this thing. I've got that one turned down up there. Go ahead and turn this one up and see if we can get it to kick on. No. I'm gonna go ahead and pick back up when this thing satisfies the top thermostat and changes over to the bottom, so we can check the amp draw on that one and see why this thing tripped. Alright, I heard this thermostat click. So let's see. So we have no amp draw on this upper element. Let's check this bottom one. We have 200 and almost 40 volts. Go ahead and check the amps and see. Sometimes you can have like a partial failure on an element where it's not pulling the same amp load across both legs. 18.5 volts, 18.4, so it's almost identical. Which our target was like, I think 19, so this thing seems to be working. I don't know why it overheated. I'm gonna click the breaker off real quick and go ahead and ohm out this top element and see. Actually, just to be safe, we'll check our line voltage coming in. Make sure I don't get zapped. 0 volts. So we can go ahead and unhook this top element. And we're looking for ohms. Go ahead and check what this ohms out. Just over 12 ohms, which I'm pretty sure that was very close to the bottom one. So, everything checks out on this guy. I don't know why it overheated and popped that. Maybe, I mean, the water was getting like quite hot to the point it would burn you. And I have not come down here and adjusted these thermostats. Our valve is open all the way. We have good water flow coming out of the faucets up there. So I wouldn't think we're like, which if there was no water in the tank, it would definitely burn an element out then. I believe what I'm gonna do is just set these down here on the hot, this first setting, because I think before I had it on A. So I'm gonna adjust it there. Hot, hot. Go ahead and leave those there. And turn this thing on and go to work. Alright, it's a couple days later now. The water heater has been working ever since I hit this thermal reset button. But it's back to doing the same thing again, even after I adjusted these thermostats down some. The water coming out of the faucet is extremely hot. It's hot enough where it'll burn you if you have the hot water turned up too much on the faucet. So I think what's happening is one of these thermostats is just not sensing the heat on the outside of the tank properly and is basically turning on the elements too frequently and too long, so that it's heating the water up too much higher than the desired setting. Because obviously from our testing last time, we found that the elements are still functioning. Sometimes, based on the reading I've done, sometimes an element, when it's going bad, will overheat because it'll get sediment or whatever on it, and that causes more resistance in the element. Therefore, you draw more amps or more current, and it'll heat get hotter than it's supposed to be. I don't know that that's what's going on with this one, because you know, we checked the current draw in each element and it was very close to what the spec should be based on the wattage. So I think we just have a faulty thermostat. So I went to Home Depot and picked this up. This whole rebuild kit was only $34. So I'm going to go ahead and install this, assuming that it actually fits. It had A.O. Smith listed here. So I'm going to go ahead and cut the power off, turn the water off, and drain it. And then we can replace this stuff. Alright, I think this thing's about drained all the way. Go ahead and extract one of these elements out of here. I already had one of these element wrenches from before. And I just want to make sure that they are the right, the new ones are the right thing before I bust that pack open. Alright, I was able to go ahead and get this repair kit installed on the water heater. It all seems to work. Only two things I ran into were on this upper thermostat here. This wire here that goes, I believe that's what goes down to this thermostat here, powering it. The wire was not quite long enough to reach where it needs to go, because on this old one, it was plugged in down here on this terminal, which is way lower down than on the new one. So I just got a piece of, I think this is 12 gauge wire, but it was the same size as this, and just wire nutted it and extended it up. I don't think that's a big deal personally. I've got, you know, an accessible panel with other terminals in it, so I don't think it's like a safety hazard or anything like that. The only other thing I did was these clips that hold the thermostat in is like this bracket that wraps around the port where the heating element goes into the tank, and it's just like a spring steel with these little clips that hold pressure and keep this thermostat pressed against the tank. But for whatever reason, this one was like rotated around a little bit sideways. So I went ahead and just stuck a screwdriver on one of these tabs and knocked it over back straight so that this thermostat sits straight on the tank. Because when it was on an angle, it was causing it to have like a little gap behind it, and obviously it's not going to accurately read the tank if it's not touching it. Alright, the water's on, tank is full. I'm gonna go ahead and turn the power on. There's our 230 volts coming in. It has the upper element energized. I did notice on these like universal style thermostats I got at Home Depot, these little protective shields don't really fit on the front quite like the factory style did. So honestly, if I was to do this again, I think I would just go to a plumbing supply house and get the correct parts for the A.O. Smith water heater like I did last time. Because I'm not crazy about that wire there, and then the fact that the shields don't match. I don't know that it's like a big deal or whatever. It'll still work fine, but I've already got this. It was convenient to get. It was only 35 bucks, and it'll get us up and going. And then later on, if it breaks or something wears out on it faster than the other ones I had, then I'll just go back to the plumbing place and get the right stuff next time. I'm gonna go ahead and call this a complete fix. So let me know what you guys think down in the comments. Am I a giant idiot for wasting this much time goofing around with a water heater? What would you guys do in this situation? I guess more of a curious person, and I would rather try to learn about things, because sometimes you can apply the knowledge you learn on one thing to something else, even though what you're working on might not seem like a big deal. I just always like to understand why I'm having to repair or replace something rather than just being a parts changer. I think it works out better in the long run, and the more knowledge you can gain, the better, because you can fix your own stuff and help your friends and family out whenever they have something come up. So, I appreciate you guys watching, and I'll catch you on the next project.